Ciao friends and welcome to a new video from SQL BI. In this video, I want to show you one of the many DAX shenanigans that you might encounter when working with composite models. We introduced in a previous video the difference between wholesale execution and retail execution of code in a composite model, depending on whether the code is entirely executed by the server, the remote server, or by the local server. And in that video, we anticipated that there is a semantic difference in the usage of ALLSELECTED when ALLSELECTED is used with no arguments in a measure defined in the remote model. In this video, I want to go into the detail of what are the differences and how you can understand them. Remember, this is one of the many DAX shenanigans. The thing is, you can expect ALLSELECTED with no arguments in a remote model to work nicely only if your code is wholesale. As soon as it is retail, the results are quite hard to understand. And also understanding the reason why the results are different is kind of complex. So what we will need to do is first start with simple queries, and then we introduce complexity one step at a time until we find the problem. And at that point, we will have gained enough knowledge to understand exactly what is happening. Let's get started. Let's start by looking at the remote model, the model that I published on the cloud and that we use as the source of our composite model. There is nothing fancy here. This is our regular Contoso model with some measures. The only measure that is worth looking at is sales ALLSELECTED. Sales ALLSELECTED doesn't do anything complex. It just computes the sales amount for ALLSELECTED. And on the remote model, it just works. You see that if I do not have any filter on the slicer, sales ALLSELECTED returns the grand total. But as soon as I place a filter on 2020, sales ALLSELECTED returns still the grand total, taking into account the filter from the slicer and ignoring the further filtering that is happening because of the visual. Then, based on this model, I created a composite model, which starts as a copy of the original model. So this is my local composite model that is slicing by year, and it's showing the sales amount, sales ALLSELECTED, with a slicer that is filtering years. And if I click on 2020, you see that sales ALLSELECTED shows the sales of 2020, even because it ignores this filter and it ignores the filter on the columns, and it still keeps the filter coming from the slicer. Now, in order to show you the behavior of ALLSELECTED, what we need to do is force the engine to execute retail queries with a very specific shape. Right now, the code executed to fill the visual is just wholesale because the local model is not using any local table. Therefore, we are going to create a local table, which is just a copy of the date table. Actually, I have already created, so we just look at the local sales table, and then we start changing the report until we find the problem. And at that point, we will have a better understanding of where the problem is, because in the meantime, we will inspect all the queries that are executed between the local and the remote engine. Let's get started by looking at the diagram. As I said, I have a local date table. Now, local date is nothing fancy. If we look at the code of local date, you see that local date is just a shallow copy of the date table. But now, this being a calculated table, it is stored in the vertical continent. I have my local date table, and I created a relationship between the sales table and the local date table. And this relationship is based on the order date, exactly as the relationship with the date table. So local date is nothing but a copy of date. The difference being local date is in the continent, whereas date is in the direct query model. Right now, I'm showing the year, the sales amount, and sales ALLSELECTED. Let's start by looking at the code that is being executed here. So I need to launch the performance analyzer, start recording, refresh the visuals, and I'm interested in the code of the matrix. So let me copy the query, and then we open DAX Studio because I want to inspect the content of the query. Let me place DAX Studio in the right place. We copy the code, both DAX and direct query, because we are interested in both queries. Now, the query executed by the engine is just using a filter 2020 for the year, and that filter is used here in order to filter the summarize column. So we are computing actually here. The S0 filter table, the filter coming from the slicer, is used here to filter our summarize columns. And then this is the local query. If we look at the remote query does exactly the same thing. It applies the filter, the S0 filter table. It runs a roll up at the subtotal. This is basically the same query executed by the local engine, but now it is being executed by the remote engine. And that's it. There is nothing fancy. The execution of this code is entirely wholesale. The results are just fine, and everything is working correctly. Now, in order to start exploiting the problem, we replace the slicer, and instead of filtering date, we filter local date. So what we do is get rid of the performance analyzer. Let me create a copy of the slicer. I place it below. And this slicer right now is filtering date year actually. Instead of filtering date, I filter the local date year. Let's place it here. Let's place filter on 2020. Right now, the filter is working on the local table. So I'm filtering the local table. Local table is filtering sales. And then I'm grouping sales by columns in the date table. So local date is right now being used only as a filter. And the results are exactly what you would expect. So sales all selected still returns the sales of the entire 2020. Now the query executed is going to be quite different, because the filter is no longer on the date table, on the date table, the remote table. Now it's working on the local table. So we launch again. Let me make it a bit simpler. We launch again the performance analyzer. Where is it? Performance analyzer. Start recording, refresh the visual, and I'm interested in the matrix. So let me copy the query, and then we paste it in DAX Studio. Now, the code of the local query is kind of the same, with the only noticeable difference between being that the S0 filter table right now is filtering 2020 on the local date year, no longer on the date year. The remaining part of the query is basically the same. There is a big difference in the code that is being executed at the remote level. Let me copy the query being executed on the remote table and paste it in a different window so we can format it. And here it is. First, we have a variable that retrieves the values of the date year, the remote table. But this is a query executed by the remote engine. Then we have this variable1, that contains, you see, the 1st of January, the 2nd of January, the 3rd of January, and so on. And this list goes on until we reach the end of December, 31 of December. So we are creating a variable that contains all the dates in a year. And then we are grouping by date year, treating var1 as if it were sales order date. So we are doing a grouping by date year, but we are treating the variable as the variable that contains just dates, and we are placing the filter on the order date column in the sales table. How comes that all selected returns the correct value? Well, actually what is happening is that the filter on sales order date is actually filtering date year. Therefore, this group cross apply will compute the value, and all selected will restore the values of the date year that are visible under the current filter, and the filter on sales order date is actually able to reach date year. because we have this var0 that contains the values of the date year. So ALLSELECTED in this scenario is still working correctly, even though, pay attention to the detail that the filter is no longer on the date table. So when ALLSELECTED restores the outer filter, it does not restore the filter on the date. It actually restores a filter on sales order date, but it is still working the right way. In order to show the problem with ALLSELECTED, we are now going to replace the values present on the columns, and instead of slicing by date, we slice by local date. And at this point, as you are going to see, ALLSELECTED no longer computes the correct value. Let me show you this. What we need to do is go here, look at sales ALLSELECTED right now. I'm slicing by year in the date table. That is broken for whatever reason, but that is not relevant right now. This is the local date. I have the year here, which is in the date table. I get rid of the columns from the date, and I replace them from the local date. So I want the year on the rows, and I want the year month short on the columns. Let me show you the result now. You see that sales amount shows a value, sales ALLSELECTED no longer shows the correct value. What is the problem here? Well, right now I'm placing a filter on local date and I'm slicing by local date. So the real problem right now is that the filter placed on local data is no longer able to reach any dimension in the remote model. Therefore, when the engine executes ALLSELECTED, it will no longer be able to restore a filter that is placed on the local date table. Remember, local date is in the local engine. The query is being executed by the remote engine. And this is no longer an wholesale query that can compute all the values. Right now, because of the way we created the visual, we are mixing remote queries and local queries, and the query that is sent to the remote engine is no longer able to restore the filter context that has been placed only on the remote table. The reason being, we are not using columns to slice by that are in the remote model. Again, let's dig a bit deeper. I'm slicing by year and month in the local date table. I'm filtering using the local date table, and I'm computing measures that are defined in the remote model. Let's go to View, Performance Analyzer, start recording, refresh the visuals, and as always, let's grab the query. Let me paste it here, everything. We have the zero filter table that is filtering the local date year. Then we have our summarize column that is grouping by local date, and applying a filter, the zero filter table that is on local date. That is the local query, so there is nothing surprising here. But as usual, it's interesting to look at the code executed in that query. Let me copy the code. We place it in a different window, then we paste everything, and we format it. Now the code is much more complex. We have one table, another table, a third table, and then a set of variables that are used to define the relationship between the dates and different values that we placed in the local table. It's interesting to see what var1 will be used for. As usual, we have one row per each date. And you see, var1 is being used here. The code now is much more complex. It's grouping by T73, T78, and T79, treating var0 as T73, 8, and 9. var0 contains just a set of values which are kind of hard to understand. But again, that is not the relevant part. The relevant part is that This is the code of var1. var1 is being used here, and var1 contains dates which are treated as sales order date. Depend on rebuilds the relationship between the variable that are used by the auto cross apply table and the one that is using group cross apply here inside. But the filter is being placed on sales order date, and we are not grouping by any column in the data model, in the local data model. Then we have a second query that is not interesting because it has nearly the same shape. So now group cross apply table is not grouping by any column in the remote model. Therefore, when ALLSELECTED is going to be executed, it will restore the filter context that is present on the group by column when group cross apply started. But the thing is, there are no filter on the local model that reflect the filter that is happening only on the remote table. Therefore, sales ALLSELECTED does not remove the filter from inside, and it just computes the value of the sales amount that you can see here from the result. Sales ALLSELECTED just computes the same value as sales amount because ALLSELECTED in this scenario cannot remove any filter. Things are very different if we define a sales ALLSELECTED measure in the local model. Look what we did here. I created a local sales ALLSELECTED that contains the very same code of the remote table, calculate sales amount ALLSELECTED. The difference being now ALLSELECTED is in the local model. So this is a measure in the local model, and being a measure in the local model, it has the entire knowledge about the model. So this ALLSELECTED will be able to restore the correct filter. If I keep sales ALLSELECTED here and I use local sales ALLSELECTED, you see that sales ALLSELECTED computes a wrong value, whereas local sales ALLSELECTED computes the correct value. I told you that is a DAX shenanigan. In order to understand exactly what is happening, you need to understand really well not only row context, filter context, context transition, the basic concepts of DAX. You also need to understand the difference between wholesale query and retail queries. Depending on whether the code is being executed by the remote server or by the local server, the knowledge that the engine has of the different tables is different, and the numbers might be computed in a different way. So, as you have seen, using ALLSELECTED in composite models, in the very special case where ALLSELECTED is used with no arguments, might provide unexpected results. By unexpected, I do not mean wrong. They are the results that the remote engine is able to compute. The remote engine has no clue about the local data. If you define tables in the local model and you apply filters on the local tables, you cannot expect the remote engine to know about those filters. If you are still slicing by columns in the remote model, then the local filter is somewhat moved to the remote tables. That is not guaranteed to always work. It depends on the relationships, it depends on the DAX code that is being written, but it's something you need to pay attention to. But if you only slice by columns in the local model and you use a remote measure that uses ALLSELECTED, then the local filter will not be restored and ALLSELECTED might produce the wrong result. That is something that a good DAX developer needs to know. Using composite models means knowing more about not only DAX, but also the architecture of remote and composite models. Once you have a good understanding, you can decide to either avoid using ALLSELECTED in your measure if you think that at some point your model can be extended through a composite model, or pay special attention to the arguments of ALLSELECTED and write the code in such a way that it will work no matter if the measure is defined locally or in the remote model. Enjoy DAX!